April 6, 1945, off the coast of Okinawa, the waters of the East China Sea. The morning came without mercy. At 0642 hours, the first Mitsubishi A6M0 appeared over the horizon, silhouetted against a sky that had not yet decided between dawn and darkness. Aboard the USS Laffey, a Fletcher-class destroyer designated DD-724, radar operators had been tracking the incoming formations for 11 minutes. The air search radar painted contacts that multiplied like a spreading stain, first 12 aircraft, then 30, then 52. The loudspeakers crackled with the announcement every sailor on picket duty dreaded. Bogies inbound. All hands to battle stations. This is not a drill. The Laffey's hull was American steel, rolled in the mills of Bethlehem, Pennsylvania, welded together in the Bath Iron Works of Maine. It was 376 feet of destroyer that displaced 2,400 tons when fully loaded. The crew had been told during their shakedown cruise that their ship could take punishment. They had been assured by Navy engineers that American metallurgy was superior to anything the Japanese could produce, that the steel in their hull represented the finest industrial achievement of a nation that had spent 4 years learning how to build weapons that could survive this war. In 7 minutes, that steel would be tested beyond anything the engineers had imagined. The belief in American material inferiority had been a cornerstone of Japanese naval strategy since before the war began. Japanese metallurgists and naval architects had long studied Western shipbuilding techniques with a mixture of admiration and contempt. The Americans built heavy, the analysis concluded. They used thick armor and redundant systems because they did not understand the spiritual dimension of naval warfare, the way that Japanese ships achieved superiority through harmony of design rather than crude mass. American steel was quantity over quality, produced quickly in massive blast furnaces that prioritized output over the careful attention to purity and tempering that characterized Japanese production methods. This assessment had some basis in reality. Japanese steel production, particularly for naval applications, involved processes that American mills would have considered economically impractical. The special treatment steel used in Japanese battleships underwent repeated folding and tempering, techniques borrowed from sword-making traditions that dated back centuries. Each sheet of armor plate for the Yamato-class battleships represented hundreds of hours of specialized labor. American shipyards, by contrast, were churning out Liberty ships in 42 days, destroyers in 6 months, using steel rolled to standardized specifications in mills that operated all the clock. To Japanese naval officers, this American approach seemed to confirm everything they believed about Western industrial culture. It valued speed and quantity over patient craftsmanship. It relied on mechanical processes rather than the spiritual dedication of skilled artisans. It produced material that looked impressive on paper but would fail under the ultimate test of combat. American steel would crack under stress, Japanese planners assured their pilots. American welds would split when struck by Japanese ordnance. American ships would burn and sink when subjected to the purifying fire of kamikaze assault. Commander Nakajima Tadashi had written this in his briefing materials for the kamikaze pilots of the 5th Kikusui mass attack. The Americans, he explained, built their ships like they built everything else, quickly, cheaply, without the soul that came from true craftsmanship. A determined kamikaze strike would shatter their inferior hulls, would prove that Japanese spirit could overcome American material advantages. The pilots who flew on April 6th believed this completely. They flew knowing they would die, but they flew also believing that their deaths would expose American weakness, would send American ships to the bottom of the East China Sea, would prove that no amount of crude steel could stand against Yamato Damashi. The first Zero dove on the Laffey at 08:27 hours. What followed was 80 minutes of continuous assault that should have destroyed the ship. The Japanese aircraft came in waves, coordinated through a tactical plan that sent conventional bombers to suppress anti-aircraft fire while kamikaze pilots selected their targets. The Laffey, stationed on Radar Picket Station 1, had been positioned precisely to absorb this kind of attack, to provide early warning for the main fleet at the cost of exposing itself to concentrated Japanese attention. The ship's crew had known this assignment was a death sentence. They had sailed to their station anyway. The attacks began with precision and escalated to chaos. A Zero came in low off the port bow, weaving through anti-aircraft fire that filled the air with tracer rounds and exploding shells. The 5-inch guns tracked and fired. The 40mm Bofors guns opened up. The 20mm Oerlikons added their voice to a cacophony of defensive fire that turned the sky around the Laffey into a wall of steel and explosive. The Zero absorbed multiple hits, its wings shredding, fuel streaming from punctured tanks, but still it came on. It struck the Laffey amidships with a force that sent a shudder through every frame and bulkhead, carrying 500 pounds of explosives that detonated on impact. The ship should have broken in half. Instead, the hull absorbed the blast. The steel buckled but did not fracture. Welds held despite temperatures that exceeded their rated tolerances. The internal compartmentation that American designers had built into the Fletcher class, watertight doors, redundant pumping systems, damage control protocols developed through hard lessons in the Solomons and the Marianas, contained the damage. Sailors manning repair stations fought fires with the kind of practiced efficiency that came from endless drills, from training that had seemed excessive in peacetime, but now meant the difference between survival and catastrophe. 4 minutes later, another kamikaze struck, then another, then 2 more in quick succession. Each impact was a hammer blow delivered by aircraft loaded with explosives and aviation fuel, flown by pilots who aimed not for superficial damage, but for the kill, targeting the waterline, the magazines, the engineering spaces where a single successful strike could trigger secondary explosions that would tear the ship apart. Each impact tested American steel under conditions that exceeded any laboratory stress test, any engineering calculation, any peacetime conception of what naval construction materials needed to withstand. The steel held. The symbolic object was visible in every frame that survived, every weld that refused to fail, the rivet. American ships of the Fletcher class were held together by millions of rivets, each one driven home by workers in shipyards who had been farmhands and factory workers and shopkeepers before the war transformed them into shipbuilders. These rivets represented the democratization of industrial skill, the idea that ordinary people, given proper tools and training and standardized procedures, could build weapons that would function as well as anything produced by traditional craftsmen. Japanese naval construction still relied heavily on welding techniques that required years of apprenticeship to master. The Americans had simplified the process, had broken it down into steps that could be taught in weeks rather than years, had created jigs and fixtures and quality control procedures that allowed them to build ships faster than anyone had thought possible. And now, off Okinawa, those rivets and welds were holding together a ship that was being literally torn apart by repeated kamikaze strikes. By 09:45 hours, the Laffey had been hit by 6 kamikazes and 4 bombs. Fires raged on 3 decks. The aft fire room was flooded. 2 5-inch gun mounts were destroyed. Casualties were mounting, 31 dead, 72 wounded. The ship was listing 7 degrees to port. Japanese pilots circling overhead reported the destroyer as finished, already sinking, needing only one more strike to send it under. The Laffey remained afloat.
Damage control parties worked in spaces filled with smoke and scalding steam, shoring up bulkheads, isolating flooded compartments, fighting fires with foam and water and desperate determination. The procedures they followed had been written by naval architects who understood that ships would be hit, that damage was inevitable, that survival depended on designing vessels that could absorb punishment and continue functioning. Every watertight door that held, every bulkhead that contained flooding, every emergency pump that kept working despite electrical failures, all of it represented a design philosophy that accepted damage as inevitable and planned for it systematically. This was the opposite of the Japanese approach. Japanese ships were built lighter, faster, with less redundancy because their design philosophy assumed that ships would either win decisive victories or die gloriously. The concept of absorbing damage, of surviving through defensive measures rather than offensive superiority, seemed defeatist to Japanese naval architects. American ships were overbuilt, over-engineered, weighed down with safety features that reduced speed and elegance. Those safety features were keeping the Laffy alive. The transformation in Japanese tactical understanding came too late and meant nothing.
The pilots who survived the attack on the Laffy, those few who had not deliberately crashed into American ships, returned to their bases on Kyushu with reports that contradicted everything their briefings had promised. The American destroyer had absorbed hits that should have sunk a cruiser. Its steel had not shattered, its structure had not collapsed. Even burning and listing and clearly damaged, the ship had continued to defend itself, its remaining guns tracking targets, its crew refusing to abandon their stations. Commander Nakajima read these reports with the sick realization that Japanese intelligence had been catastrophically wrong about American metallurgy. But what could be done with this knowledge? The Kamikaze strategy was already committed. The special attack units were already organized. Thousands of pilots had already been told that their sacrifices would be meaningful, that American material superiority could be overcome through spiritual dedication and tactical surprise. The truth that American ships were built with a resilience that reflected genuine engineering excellence rather than crude quantity could not be admitted without undermining the entire strategic premise of the Kamikaze campaign. So the attacks continued. More pilots died, more American ships were hit, and occasionally, when the damage was severe enough and the luck ran against the Americans, ships did sink. But they sank less often than Japanese planning had required, and they died harder than Japanese intelligence had predicted. The Laffy limped back to port under its own power. The shipyard workers at Puget Sound Naval Yard studied the damage with professional fascination, the way stress fractures had propagated through frames without causing catastrophic failure, the way emergency repairs made by the crew had held despite being executed under combat conditions, the way the overall structure had maintained integrity despite localized destruction that looked like it should have been fatal. The repairs took 3 months. When the Laffy returned to service in July 1945, it carried the same hull number, the same basic structure, rebuilt with the same American steel that had survived April 6th. The ship that Japanese pilots had reported as sinking was back in operation, rebuilt by the same industrial system that had produced it in the first place, demonstrating a capacity for regeneration that was perhaps more demoralizing than the initial survival. The naval architects who studied the Laffy's survival drew conclusions that reshaped post-war shipbuilding. The American approach to metallurgy and ship construction had proven itself under the most extreme test imaginable: repeated impacts from suicide aircraft carrying high explosives. The steel had performed not through superior purity or exotic tempering processes, but through consistent quality control, through specifications that prioritized reliability over theoretical maximum strength, through a production system that could deliver the same properties across millions of tons of material.
This was the lesson the Japanese naval strategists had missed, that industrial democracy could produce excellence through standardization rather than through aristocratic craftsmanship. The workers in Bethlehem, Pennsylvania, were not master swordsmiths. They were ordinary Americans operating machinery according to specifications written by engineers who understood that modern warfare required materials that could be produced at scale without sacrificing essential properties. The rivets that held the Laffy together were not individually superior to Japanese rivets. They were, collectively, part of a system that worked, that had been tested through earlier battles, refined through engineering analysis, improved through the kind of systematic feedback that an industrial democracy could implement faster than any imperial bureaucracy. When Emperor Hirohito's surrender announcement reached the scattered remnants of the Kamikaze units in August 1945, some pilots wept not just for defeat, but for the waste. They had been promised that American material was inferior, that spiritual strength would overcome industrial capacity. They had died by the thousands testing that promise against American steel, and the steel had held more often than their officers had predicted. The epilogue was written in dry, technical language in naval architecture journals. Post-war analysis of the Laffy's survival and the survival of dozens of other American destroyers that absorbed kamikaze strikes revealed that Japanese assumptions about American metallurgy had been inverted. American steel was not brittle for mass production. It was consistent in a way that artisanal production could never achieve. The quality control measures that Japanese observers had dismissed as mechanical and soulless actually ensured that every plate, every beam, every rivet met minimum specifications that were, collectively, more reliable than the variable excellence of handcrafted materials. The Laffy itself survived until 1975, when it was decommissioned and eventually became a museum ship at Patriots Point in Charleston, South Carolina. Visitors can walk its decks and see the reconstructed damage, the metal that bent but did not break, the rivets that held when everything else seemed to be failing. Few of them understand that they are looking at a monument not just to the crew's courage, but to a revolution in industrial philosophy. The Japanese had believed that quality came from spiritual dedication and individual craftsmanship. The Americans had proven that quality could come from systematic processes, from standardized procedures, from the kind of consistent mediocrity that, when multiplied across an entire industrial base, became excellence through sheer reliability.
This was more than a question of metallurgy. It was a question of ideology. Could a democratic society, which valued individual freedom over collective discipline, produce materials as good as those created by artisans working within hierarchical traditions? The answer, forged in the waters off Okinawa and proven in the survival of ships like the Laffy, was that democracy could do something better. It could produce reliable excellence at scale, could turn ordinary workers into producers of extraordinary materials through systematic training and quality control. The kamikaze pilots who dove on the Laffy were brave. They were dedicated. They believed in their mission with a fervor that American sailors could only respect. But they were flying into steel that represented a truth their commanders could not accept. That the American way of making things, quick, standardized, produced by workers who questioned authority and went home at the end of their shifts, was not a weakness, but a different kind of strength. The rivets held, the welds held, the steel that Japanese officers had dismissed as brittle and inferior absorbed punishment that should have been impossible and returned to service to absorb more. This was not because American steel was spiritually superior or because American workers possessed some mystical dedication. It was because American industry had learned to build consistency into every process, to replace the variable excellence of craftsmanship with the reliable adequacy of standardized production.
And in war, where thousands of ships needed thousands of tons of steel, reliable adequacy multiplied across an industrial base proved more valuable than perfected excellence, available only in limited quantities. The Laffey still floats in Charleston Harbor, a testament to steel that refused to be brittle, to welds that refused to split, to an industrial philosophy that won not through individual superiority, but through systematic competence. The Kamikaze pilots are gone, their beliefs about American material weakness buried with them in the waters they died trying to prove correct. The steel remains, holding together a ship that should have sunk, proving every day that it floats that sometimes the greatest strength comes not from perfection, but from the humble reliability of things built well enough, consistently enough, by ordinary people doing ordinary work in a society that trusted standardization over inspiration.